Hi, kids. So today is Tuesday, February 7th, and this is our math lesson for today. It's a little hard. I think it's hard. It's 8.06, miles and tiles, and we're starting to work on some area problems. So we haven't done much with area this year. And here's the lesson. Here's where it starts. You're going to need to take your time and do this one carefully so you understand it. So here we go. The feast is ready. The food smells delicious. Uncle Kobe and Aunt Steph clear some area to put the food on the table. There's a small area for all the food. You're going to learn how to find the area of a rectangle with a fractional side length by tiling it with unit squares. Find the area of a rectangle with fractional side lengths by multiplying the side lengths, and represent fraction products as rectangular areas. So let's just do a really quick reminder of what are we talking about when we're talking about area. I'm going to set up a new whiteboard and open it. Grab a pen and just remind you of area. So when we are talking about area of a shape, let's say we're connecting these dots together and we go down here, and let's say we go 2 down and 4 across. Just a minute. All right. So if my little shape here is 2 down and 4 across, and if I had tiles on it, then my surface area would be this side, 2, times this side, length times width. In other words, 2 times 4, which would equal 8 tiles. Let's see if we've got 8. 1, 2, 3, 4, 5, 6, 7, 8, right? 5, 6, 7, 8. All right. So remembering that area is length times width, let's go to today's lesson using fractions. 806, here's the first page, and we're going on to the second page. Maybe, if the computer will comply. Here we go, page 2. Where are you with area? Sometimes we multiply fractions when we're baking, building, or even when we're setting up for a party. I often have to, like if I'm doubling a recipe, I use fractions. Solve each of the following multiplication equations and then select the correct options. 3/9 times 1/2. So what's 1/2 of 3/9? Well, we've learned that when we multiply fractions, we multiply the numerators and the denominators. 1 times 3 is 3. Here's the 3. And 2 times 9 is 18. 3/18. Oops, here it is, 3/18. Click, submit. What a wonderful job. Your brain is expanding a great deal. Great job remembering how to multiply 2 fractions together. Next. Here's another one. 4 times 4 across the top is 16. 5 times 6 is 30. Oh, it's this one. Okay. When we find how much space a flat shape covers, we're finding the area of the shape. One way to find the area of an object is to cover it completely with squares. Each side of the square is 1 unit in length, so we call them unit squares. We can place unit squares to cover an area and then count how many we place. This tells us what the area is in square units. To find the area of a rectangle using square units, we need to make sure that there are no overlapping squares or gaps, so not like the middle one. Let's watch this video to learn more about area. We will learn how to find the area by counting.
Have you ever wondered how much space this takes up? Or this? Or even this? If so, then you've been wondering what their areas are. Area is the amount of space inside an object, measured in square units. Let's start with this book. All the space it takes up on the table is its area. We can use unit squares to measure the area of an object. A unit square is a square with sides that have a length of 1 unit each. Let's give it a try. To find the area of this square, we'll lay unit squares inside it. Each square must be the same size. When you lay them down, make sure there aren't gaps or spaces between them. As you measure, remember to keep the unit squares from overlapping. Once we lay down the unit squares so they're all touching, we can count how many we used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This square's area is 16 square units. Now that you know how to find an object's area, what else could you measure with unit squares?
And the good thing about that is seeing that sometimes if you're measuring a shoe, you're not going to come out with an even amount of whole numbers. You're going to use fractions. On a farm, it's important to know how to calculate area. Aunt Steph and Uncle Kobe, you need to make sure the chickens have enough area so they're happy and lay eggs. Thought they were setting the table, but now they're laying eggs. We can multiply a mixed number by a fraction. To do this, we can rewrite the mixed number as an improper fraction. And we did that yesterday. We said to ourselves, let's change 6 into fifths. Each one whole of the 6 is 5/5. So if there's 6 of them, 5 times 6 is 30 of them. 30 over 5 plus 4 over 5 equals 34 over 5. We did that yesterday. So here you can see the 6 5/5 to make it. Moving on to page 3 of the lesson. Uncle Kobe makes furniture. He uses area to know how big or small to make each piece. Let's help him make a new table. The dining room table has a length of 5 meters and a width of 3.5 meters. What is the area of the table? Like, how big of a piece of wood is he going to need? Step 1, we can use a square grid to help us find the area. Each square on this grid is 1 square meter. This little 2 up here, this exponent means squared. To find the area, we shaded 5 tiles to represent the length of 5 meters. Okay, 1, 2, 3, 4, 5. Step 2. Now we will shade in the width, which is 3.5 meters. So it doesn't go all the way down. So we shaded in 3.5. Great. Step 3. We have tiled the area of the table, which has a length of 5 and a width of 3.5 meters. Let's count the unit squares to find the area. There are 15 whole, or 3 times 5, 15 whole squares. And there are 5 half squares. So if we push these 2 together, it makes 1. That's 16. These 2 together, it makes 1. That's 17. And we have a half a meter left. We can add the halves and get 5 halves, which we know is 2.5, because we take 2 halves out of there and 2 halves out of there. So 17.5. 15 holes plus these halves that we can push together. Well, that's nice, but we've got to come up with a way to do that without having to tile everything. We know now that another way to find area is by multiplying the side lengths without doing all that tiling. This means that we multiply the length by the width, and we get the same answer as if we were using unit squares to tile. Follow along with the video for a refresher in finding area.
Welcome to the zoo. We have a special new animal arriving. It's a giant polar bear. To build the bear's new cage, we need to know the cage's area. The area is the amount of space inside an object, measured in square units. Let's review how to use unit squares to find an area with this shape. Line up unit squares inside the shape, and then count them to find the area. Here we can count 24 unit squares. So we know the area of our shape is 24 square units. A great trick for finding an answer quickly is to use multiplication. Multiply the length times the width to discover the area. To do this, we need the length and width of the rectangle we're looking at. Length is the measured distance from one end to the other of the longer side of something. The length of our polar bear cage is 6 meters. Width is the measured distance from one end to the other of the shorter side of something. The width of our polar bear cage is 4 meters. Multiply the length and the width to calculate the area. Write this as area equals 6 times 4. Remember, Multiplication is like repeated addition. If we skip count by 4 6 times, we can find the answer. 4, 8, 12, 16, 20, 24. So,
Okay, so I think you remember how to find area. So then how do we do area when we go to fractions? Uncle Kobe needs to build a chair, but he needs to make sure the base of the chair will be the right size for his friend. He has the dimensions for the rectangle that he'll use, and now he just needs to find the area. So this chair is 2/3 of a foot by 4/6 of a foot. Step 1, we need to find the area of a rectangle that has a length of 2/3 of a foot and a width of 4/6 of a foot. As each of the measurements is less than 1 foot, we'll draw a square fraction model that represents 1 square foot. We'll partition it to help find the area. Step 2, the length of the area is 4/6. So we broke it into 6 and we colored in 4 of them. Remember, we did that vertically. This is just like we did earlier when we were multiplying fractions. The width of the area of the rectangle is 2/3. So this time we're going to break it into 3 pieces horizontally the other way and shade in the 2/3, 2 out of the 3 parts. So here we have 1/3, 2/3 shaded in. We already had our 4/6 shaded in, and we look at the part that is shaded both ways. If I were drawing lines in here, you'd see 2 colors on that part. Okay, so now we have the 4 of the 6 and 2/3, and let's see what step 4 is. To find the total area, we first need to know the area of one part. To find the area of one part, we multiply its length and width, which is 1 foot times 1/3. 1/6 foot times 1/3. Multiply the numerators. 1 times 1 is 1. Multiply the denominators. 3 times 6 is 18. 1/18. If you counted right now, there would be 18 little. All right. Step 5. Now that we know the area of each part is 1/18, we can find the entire area of the rectangle by counting the dark gray squares, and we have 8 of those 18ths colored in. Hi, Evie. Thanks for joining. You have a choice today of staying here for the lesson or listening to it later. I'm recording it and then going to a breakout room and playing a game. There's kids in there playing right now since it's our online game day.
Okay.
This is 8.06. We could have also solved this by multiplying the length of the rectangle, 4/6, by the width of the rectangle without making the model. So here we would multiply the numerators. 2 times 4 is 8, and multiply the denominators. 3 times 6 is 18. Pretty easy. 8/18 feet, and this little 2 up here, the exponent says squared feet. Shows that the feet aren't just linear, but that they have length and width, 2 dimensions. We got the same answer. Great. Let's go to the next one. You're getting good at this. Uncle Kobe has different tools to cut the wood. He picks the tool that's best. He's been asked to build a bookshelf. He has the measurements, but he needs to find the area. Let's help him with his new project. What is the area of a rectangular bookshelf that has a length of 6/8 yards and a width of 2/5 yards? So we can do that just using the numbers, where we multiply the numerators. 2 times 6, which is 12. And then multiply the denominators. 5 times 8, which is 40, 12/40. Or we can try and look at it like this. So here we've drawn the picture, the 2/5 on one side, the 6/8. That's a lot of work to divide this into 8 pieces, color them in, and then divide this into 5 pieces and color in 2 of them. So let's see. So in this case, they just did it the way we did it by multiplying 12/40. Nice. Uncle Kobe enjoys making furniture for other people. He has an order from his neighbor and he needs to figure out the area. So here's another example. What is the area of a table with a length of, we have a mixed number, 2 1/4 and a width of 1 1/2. What do we need to do this time? Well, we learned yesterday that we can take a mixed number and make it into an improper fraction. So we need to rename 2 1/4 as a mixed fraction. Let's see what they say here. Here they had you draw it just like that, showing the 1 1/2 and the 2 1/4. Then they had you measure it all out. Sometimes I think these models, they're trying to teach you so that you understand what's happening, but they can be very confusing. So they just split the number up like we did before into the whole meters and the fractional meters. Then they multiplied each of the 4 areas. Do you remember when we did that with numbers when we were doing multiplication and we broke them into models? They found all the partial areas. That's the partial area model. Or we can change it into improper fractions. So this is showing you how to change it. You're saying to yourself, well, what is 2 1/4 in quarters? Well, each one of the 2 wholes is 4/4. So if each one of these is 4, I can just go 2 times 4, which is 8, and make that 8/4 plus 1/4, which is 9/4 is another name for 2 1/4. In this case, I'm changing my 1 into halves. Each whole 1 is 2 halves. So 2 halves plus 1 more half makes 3 halves. This is kind of a funny drawing here, but that's all they're telling you is how to change the names of those numbers. Now, if we have 9/4 times 3 halves, we can easily multiply the numerators, multiply the denominators, and we're done. We get an improper fraction, 27/8. We can see with that big number on the top, then that's a lot of whole numbers, isn't it? So all we have to do is change 27/8 back to a mixed number. We have to take the 8/8 out of there. So how many 8/8 can we take out? Well, 3 times 8 is 24. So that's 3 wholes is 24/8. And there's 3 more 8ths left over. So there it is, 3 wholes and 3/8 meters squared. Now we know how to find area when the side lengths are fractions. Show off your new skills in the sketchbook activity. And they have an activity here that you should do and the answers here for practicing. Solve each of the following questions and then select the correct option. So here you're going to do some multiplying. 6 times 2. You have to make sure they're both meters. Your units need to be the same. So meter is the unit you're using here. They're not going to change it up on you now, but in math, you always need to pay attention to those little labels. 2 times 6 is 12. 3 times 7 is 21st. 12 21s. Let's see if we got it right. Woohoo! Excellent work. Our brain is working. All right. So once you've practiced that, then you're going to be asking me, what's my assignment, Ms. Laws? Let's go on to the last page. They have some more summary here of what you learned about how to multiply fractions, how to find the area. And then on page 6, you have an assignment today, smile and tile. If you click on this, it will open up to the smile and tile page. And you need to follow the instructions for each question below. Use the square grid to find the area. I'm going to open this with Cami and demonstrate one example of how I would fill this in. So with my Cami right now, I need to use my square grid to find the area. I need to color in 4 centimeters one way and then 1 1/4 the other way. Okay. So I'm going to take and first of all, color in my 4 centimeters with little lines. I think I'll just do lines. So drawing, I'll make them red. And I've got 1, there we go. 2, 3, 4. So these are my horizontal centimeters. You can see right here, I have 1, 2, 3, 4. 4 centimeters right there. So that's the first number, 4 centimeters. The other one, 1 1/4 centimeter. I'm going to change to, oh gosh, green is good. I'll change to green. Now I did this one horizontally for this way. So I'm going to go this way this time. And I've got 1 hole. So let me put it right here, 1 hole. So here I'm going to color in my 1 hole. Ooh. Okay, that's my 1 centimeter. So this is split into centimeter measurements. And then I have 1/4 of this centimeter. So I'm going to have to break this one into 4 little pieces, which is going to be kind of hard to see. So there's 1, 2, this is terrible drawing, 3, 4. Pretend that those are equal. And then I'm just going to color in the first one here. Blink, 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 blink. Okay. So what I come out with is 1, let me go to black. So here I have 1 hole, 2 holes, 3 holes, 4 centimeters, right? I've got 4 whole centimeters. And then how many fourths do I have? Well, I have 1/4 right here, another fourth here, that's 2/4, 3/4, 4/4. Huh, 4 and 4/4, is there another name for that number? If I stuck all of those fourths together, I think it would fill up this square and make a 5th centimeter. So that one comes out 5 centimeters, and you write it like this with the little label of centimeters and the little square to show that it's squared. That's how I would fill this in. I would fill it in by filling in the 3 hole, 1, 2, 3, and then 3/4 of this last one across. And then I'd go 2 hole and then a half of the next one and count it all up. But as you get down here, it says find the area by using fraction models. When you get into this, I think you don't have to do it by breaking it up. If you want to just use the numbers, that's okay with me. So in this case, I would go 3 times 4, 3 times 4, the numerators, which equals 12. And then the denominator, which is 5 times 8, which is 40. And make sure you know those math facts. They're very helpful. 12/40. You do not have to draw in. I don't want you to have to break that into 5 and break this into 8, but if you want to, you can. If you prefer to do it this way, where you go, let's see, I'll break this into 4 parts and I will color in one of them. If it is helpful to you to do it this way, then do it this way. And then I'm going to break this into 7 parts. Wow. 7 is not an even number, so I know there'll be 1 in the middle and 3 on either side. 1, 2, 3, 4, 5, 6, 7. There's 7. And I have to color in 3 of them. 1, 2, 3. I don't even know if you guys can see that. Now I ask myself, what part is colored in both colors? Well, I have this one.
1, 2, 3.
Out of how many? Well, gosh, there were 7 this way and 4 this way, and 4 times 7 is 28. So if it helps you, you could count up all these little dots. 1, 2, 3, 4, 5, 6, 7. 7 and 7 is 14, and 7 more is 21, and 7 more is 28. Okay, 3 28s. Find the area of the rectangle by using fraction models and using multiplication. What should be true about your answers? Well, what should be true? They should be the same, silly. Of course. Find the area by using fraction models and multiplication. I'm going to show you one thing more, because on this one, you are probably going to want to convert this into an improper fraction. So here you've got 2 times 3 3/4, right? So to change that into quarters, you're going to say to yourself, well, each one of these 3 is 4/4, and I've got 3 of them. So that's how many fourths? That's 12/4, because 3 times 4 is 12. 12/4, which is the same as 3 holes, plus 3/4, which is going to be 15/4 times 2 holes. All right. I think you can do this, and then you submit it, you save it and submit it. Any questions, my 2 guys who are listening?